you can build a shelter today with factory-made materials delivered straight to your door. Prefabricated beams, metal roofing, synthetic sealants, and power tools can turn an empty space into a finished structure in just a few days. Yet for thousands of years, builders had none of those advantages. Everything came directly from the landscape around them. The timber, the clay, the fuel, even the tools. And somehow they still created shelters strong enough to survive seasons of rain, wind, and sun. Today, we're following the process of building a tiled roof shelter using only forest timber and natural materials. No machines. No modern construction supplies. Just wood, clay, fire, and skill. The question is simple. Can a durable roof emerge from nothing more than the resources of a forest? Modern construction is built on speed. Trees are harvested by machines, cut in industrial sawmills, and transported hundreds of miles before reaching a building site. Roofing materials are manufactured in factories using complex equipment and synthetic additives. Most modern systems prioritize efficiency and low cost. Traditional builders faced a different challenge. Every material had to be gathered and processed by hand. The shelter begins with timber harvested from the forest. Straight trunks are selected for structural strength. Smaller poles become roof supports and braces. Clay is collected from damp soil near streams and riverbanks. When shaped and fired, it becomes durable roofing tile capable of shedding rain for decades. Charcoal provides concentrated heat for firing the clay. Plant fibers are twisted into cordage for measuring, tying, and securing materials during construction. Even simple iron tools depend on natural resources. Thor, charcoal, and fire once formed the foundation of metalworking. To traditional craftsmen, these materials were valuable because they were local, renewable, and well understood. Success depended on knowing exactly how each material behaved. The workshop sits in a small clearing beneath tall trees. Fresh logs lay stacked beside piles of clay. Wood shavings cover the ground like curled ribbons. The smell of cut timber hangs in the air. Nearby, a charcoal fire burns steadily. Thin smoke drifts upward through shafts of sunlight breaking between the branches. A few simple tools rest against a stump. An axe, the wooden mallet. Iron chisels darken from years of use. The timber is rough and unfinished. Bark still clings to portions of the logs. The craftsman studies each piece carefully before making the first cut. Then the work begins. An axe rises and falls. The sharp crack of splitting wood echoes through the forest. A log opens along its grain. Wood chips scatter across the ground. The rhythm continues. Cut, split, trim, shape. Occasionally sparks jump from hot iron being sharpened near the fire. The workshop is quiet except for hammer strikes, scraping blades, and the sound of timber being transformed into building material. Slowly, the shelter begins to exist. Construction starts with the main support posts. Straight timber is cut to length and stripped of bark. The posts are positioned upright and set firmly into the ground. Their weight creates stability and forms the skeleton of the shelter. Crossbeams are lifted into place. The craftsman carves joints into both beams and posts. Rather than relying on nails, these joints allow the structure to lock together mechanically. Each connection distributes weight across multiple surfaces. The frame gradually grows stronger. Fresh timber is easier to shape than dry wood. The fibers remain flexible, making it possible to carve clean joints and adjust alignment before the wood hardens. Next comes the roof structure. Long poles are cut and stacked across the frame. The angle of the roof is carefully chosen. A steeper slope allows rainwater to flow away quickly, reducing the chance of leaks and water damage. With the framework complete, attention shifts to the tiles. Clay gathered from the forest floor is mixed with water. The craftsman kneads the material repeatedly, removing stones, roots, and air pockets. The clay becomes smooth and dense. Each handful is pressed into a simple wooden mold. One tile after another takes shape. Rows of fresh tiles are laid out beneath the sun. Moisture slowly evaporates. The surface is hardened enough to survive firing. The firing process begins with a carefully built kiln. Wood and charcoal are stacked in layers. The dried tiles are arranged inside with small gaps between them. These spaces allow heat to circulate evenly. The fire is lit. At first, only smoke emerges. Then the temperature climbs. The glow of charcoal deepens from dull red to bright orange. Heat radiates from the kiln walls. Inside, the clay undergoes a transformation. Water trapped within the material escapes. Minerals fuse together. Soft earth slowly becomes ceramic. Hours later, the fire dies down. The tiles cool gradually. When tapped together, they produce a hard, sharp sound. Now the roofing can begin. This tile is carried to the frame and placed by hand. The tiles overlap in neat rows. This overlapping pattern directs rainwater downward while protecting the timber beneath. Lift, place, align. Repeat. The growing roof becomes heavier with every row. The timber frame settles beneath the load exactly as intended. As the final tile is positioned, the shelter takes on a completely different appearance. Wood, clay, charcoal, and human effort have become a weather-resistant structure built entirely from natural resources. Section 5. Why we stopped building like this 450, a 550. Methods like these were once common across much of the world. But industrialization changed construction forever. Factories could produce roofing materials faster than individual craftsmen. Machines could process lumber in minutes rather than days. Mass production lowered costs and increased availability. For growing towns and cities, speed became essential. As factory-made materials spread, many traditional skills became less necessary. Fewer people learned how to shape timber joints. Fewer communities fired their own clay roofing. Knowledge that had been passed from master to apprentice gradually faded. The materials remained the same. Wood was still wood. Clay was still clay. Fewer people understood how to transform them using traditional methods. Efficiency replaced craftsmanship as the dominant priority. Section 6. What you can learn from this today. 550 END. Even today, these building methods offer valuable lessons. The first lesson is understanding materials. Every material has strengths and limitations. Good craftsmanship begins by learning how those materials respond to moisture, heat, weight, and time. The second lesson is durability. Traditional builders often created structures that could be repaired piece by piece rather than completely replaced. The third lesson is patience. Many of the strongest results come from slow preparation rather than rapid construction. Most importantly, this shelter reminds us that technology is not defined by complexity. Technology is knowledge applied to materials. A tree becomes a beam. Clay becomes a tile. Charcoal becomes heat. Skill transforms natural resources into something useful and lasting. Standing beneath this finished tiled roof, it's easy to see why traditional building knowledge survived for generations. It worked. Not because it was fast, but because it understood the materials completely. If you enjoyed this exploration of primitive construction and traditional craftsmanship, be sure to subscribe for more videos on forgotten technologies and historical building techniques. And let us know in the comments if you could learn one traditional building skill from the past. What would it be and why?